Next, let's analyze this op-amp circuit with positive feedback with the characteristic that virtual open is tenable but virtual short isn't. You should notice that a part of the output signal feeds back to the non-inverting signal. Let's analyze the characteristic curve of the input and output. The output of the op-amp circuit with positive feedback is either positive U-set or negative U-set. We suppose that output is positive U-set. There is no current here due to virtual open, so this part is a voltage division circuit. When the output is positive U-set, U positive is half of U-set. As long as the input, that is the inverting input voltage, is less than half of U-set, the output keeps positive U-set. This is a characteristic curve of input versus output. Once the input is greater than half of U-set, the inverting input is greater than the non-inverting input. Due to the characteristic of positive feedback, the output changes to negative U-set very fast. The increase of input makes that the inverting input is much higher than non-inverting input, so the output keeps negative U-set. When the output is negative U-set, this part is still a voltage division circuit. U positive is half of minus U-set. If the input is greater than minus half of U-set, the inverting input is greater than non-inverting input, and the output keeps negative U-set. This is a characteristic curve. Once the input is less than minus half of U-set, the non-inverting input is greater than the inverting input. Due to the characteristic of positive feedback, the output changes to positive U-set very quickly. This is the characteristic curve of op-amp circuit with positive feedback, in which the output is always lags behind the input. So the circuit is called the hysteresis comparator. Another point is that the resistance in the voltage division circuit are the same here. So the breakover voltage is negative half of U-set and positive half of U-set respectively. We can change their resistance to change the value of the breakover voltage. And the width is called the hysteresis width. You will find that the hysteresis width can be changed by adjusting the ratio of the two resistance. We won't discuss this in detail. Let's see an experiment of the hysteresis comparator. This is the experiment circuit of the hysteresis comparator. It consists of 3 op-amps. The first one is the voltage follower, whose effect is to cancel the impact of the voltage source internal resistance. The second op-amp circuit is the ANDR, whose effect is to enable the input of DC and AC. The third is the hysteresis comparator. The experiment has 2 parts. The first is that the input signal is DC. It transferred to one input through the voltage follower and to the inverter input of the ANDR. We observe the input-output waveform of the hysteresis comparator in this way. The second is that AC signal on the board is connected to another input terminal of the ANDR, and the ANDR's output is connected to the inverting input of the hysteresis comparator. We will observe the input-output of the hysteresis comparator in this way. And the input of hysteresis comparator is connected to the channel 1 of the oscilloscope. And the output of the hysteresis comparator is connected to channel 2. This is the input DC voltage and output waveform of the hysteresis comparator with virtual oscilloscope. The input voltage is negative and less than the voltage of non-inverting input. The output of the hysteresis comparator is positive. Now we increase the input voltage. Make it change from negative to positive gradually. When the input is greater than non-inverting input, the output hysteresis comparator turns over from positive to negative. Then we decrease the input voltage, make it change from positive to negative gradually. When the inverting input is less than the non-inverting input again, the output of the hysteresis comparator turns over from negative to positive. Now the input is a voltage signal, AC. The yellow curve is the input, and the green curve is the output. When AC signal increases to greater than the non-inverting voltage, the output turns over from positive to negative. When the input decreases from positive to negative is less than the non-inverting input, the output turns over again from negative to positive. So the circuit realizes the function of a hysteresis comparator. Let's make a comparison now. This is a comparator, and this is the hysteresis comparator with positive feedback. There are two input-output characteristic curves, respectively. According to previous analysis, we find that the output of the comparator keeps up with the input immediately, but output of the hysteresis comparator lags behind the input. What's the purpose of studying the hysteresis comparator? Please look at this example. The measured signal in our daily life may contain noise. If we use such a sensitive comparator, the output may be like this. This output is a disadvantage for our control based on the input. If we adjust the circuit with suitable hysteresis width, it's very possible that not until the output is really less than some negative value and greater than some positive value does the output change. The output lag behind the input a little, but its trend fits the change of the input very well. So the hysteresis comparator is one of the most important measures of resisting noise. In fact, almost all the comparators available in the market are hysteresis comparators.